G'day, it's Professor Glenmo here again, and I want to talk to you about solar cell technology and some of the amazing improvements that come about through the development of small changes in the way we manufacture solar cells. Many of these changes came about as a result of the University of New South Wales PV division, led by Professor Martin Green, and with the help of his team. In fact, I don't know why he hasn't got a Nobel Prize for what he's done so far to reduce the cost of solar cells and produce more renewable energy for our planet. So good on you, Professor Martin Green. So let's go through some of these technologies. Now, take you back, way back to 1955. Now, that was when the first modern solar cell was produced in the RCA labs. It was only 5% efficient. We've come a long way since then. We're more than 400% improvement on the 1955 approach. So, what are some of these acronyms? You might have heard of PERC, HJT, TOPcon, IBC, XBC, you name it. Well, these are just some of the small changes that were made to improve the efficiency of a solar cell. So let's start with PERC, Passivated Emitter Rear Cell. Now this is where passivating the emitter and the rear surface of the solar cell improves the efficiency and reduces losses. That was one of those wonderful steps forward that came out of the University of New South Wales research. Then we've got HJT, Heterojunction Technology. Now HJT is a way of kind of getting 2 bites of the photon that comes from the sun or the light source. Basically we've got 2 junctions, and often these are materials that have different band gaps. What on earth is a band gap? Well, it just determines what part of the light spectrum a solar cell and the junction within it is sensitive to. So by combining semiconductor materials with different band gaps, you get kind of 2 bites of the solar cherry. That's a good one. So HJT. Then we've got TOPcon. Now this is a bit of a mouthful. Here we go. Tunnel oxide passivated contact. Whoa, try saying that after a few beers. So TOPcon is incorporating the tunnel oxide layer of a passivated contact. Now, whoa, that sounds really high tech. Don't you worry yourselves about it too much. It's just yet another way of improving the efficiency of a solar cell. And lastly, we've got IBC. Integrated back contact. I love it. Sometimes called XBC because the prefix can change in terms of that back contact. But these are little strategies to reduce the self-shading losses within a solar cell. Anyway, all of these technologies have made for cheaper, more efficient and longer lasting solar cells. And as I said at the beginning, many of them came about as a result of Professor Martin Green and his team at University of New South Wales. So hats off, Professor Martin Green. This is Professor Glenmo, out.